So today we'll continue the factoring. Last time we learned how to factor using the GCF and the and factoring by grouping. Today we're going to see two other methods of factoring. Namely, there are two special ways of factoring, two special ways or methods. One of them is trinomial factoring, and the other one is called difference of two squares factoring, another way. So these are pretty special. When the first two we learned the last time don't work, when the GCF and the grouping don't work, then we have two other methods that we can try. So the first one is called trinomial. So trinomial factoring. So obviously this involves trinomials with three terms, and we use this when again the other two don't work, when a GCF, when you don't have a GCF and you can't use grouping. So we try trinomial factoring. So trinomial has three terms, of course, and mostly we're going to be seeing trinomials with second degree and sometimes third degree. The second degree will look like this: some ax to the second plus bx plus c. This is a standard form of actually not. Yeah, that's good. That's good enough. So this is a trinomial of second degree. So this is the standard form of all trinomials with second degree. And we have a special way of factoring these. Even if you don't have a common factor, you can still factor them. And the way this works is, for example, if you have x to the second plus, let's say 5x plus 6, that's trinomial, three terms. And, of course, I'm going to factor it, but as you can see, there's no GCF. There is no common factor. X is not a common factor because it's not here. No number is common. So that's where we need to try something called trinomial factoring. And the way it works is simple. First, if you have a trinomial of second degree and the coefficient here is an invisible one, so if a here is 1, as you can see, there's an invisible 1 here. So if a is 1 and the degree of the polynomial or the trinomial equals 2. If we have 1 here and 2, and it's a trinomial, only if these two conditions are met, then we can turn this immediately into two sets of parentheses like this. Even though we don't have a common factor, we can start this by writing two sets of parentheses. Then we start each one with x, or whatever the variable here is. And then we just need to find a couple of numbers to put in the parentheses, and the factoring will be done. So again, because this is,
right?
That's right. So because again, there's no common factor, as you can see, there is no GCF. We have three terms. So we have a special way of factoring called trinomial factoring of second degree trinomials. This is a second degree trinomial. So again, you check if we have 1 here and 2. 1, a basically is 1, and the degree is 2. We can immediately write two sets of parentheses and start each one with x. Only again if you have 1 here and 2. And we find two numbers. The way we find the numbers is simple. The numbers that we find, two of them, two numbers that multiply to this, to c, two numbers that multiply to c. And the same numbers we use here, when we combine them, whatever their signs are, when we add or subtract them, we should get this number here, b. Okay, let me repeat that again. So we're looking for a couple of numbers that multiply to c. multiply to C. In this case, C is 6. Same numbers add up or subtract to B. Okay, B here is 5. So two numbers that multiply to 6, same numbers. When we add them or subtract them, we get 5. The numbers are, what are the numbers that multiply? Multiply to 6, and the same numbers, if we add them, we get 5. What are those numbers again?
2 and 3.
2, that's right, 2 and 3. So 2 times 3 is 6. And if we add them, we combine them, so it's positive 2 and positive 3. So positive 2 and positive 3. If we add them, we get 5, or B. So these are the numbers we're looking for. So all we need to do is put these numbers here. So the numbers are positive 2 and positive 3. Okay, so again, when you have a trinomial like this, second degree, and there's an indivisible one here. So if you don't have a GCF, if you don't have a common factor, there's no common factor here, then we can use trinomial factoring, or it's a special way of factoring. So we start two sets of parentheses, then we look for two numbers that multiply to this number, whatever this number might be, happens to be positive 6. Same numbers we use here, they must multiply to this number here, B. So we may have to work or change the signs a little bit. Sometimes if there is a minus here or both, so we have to work with the signs, change the signs a little bit. But if both are positive, as you can see here, C is positive, B is positive, then it's easy to find the numbers. So that can be done usually in seconds. Okay, this can be done immediately, one step. With experience, you'll see that it can be easier to find these numbers right away. That's a special way of factoring again. If you don't have the GCF. GCF doesn't work, you can always use this method. So let me give you another example. So let's say x to the second plus maybe 7x plus 12. So again, we have a trinomial. As you can see that we want to factor. And first look for a GCF if there is one. There is no GCF here. So if there is no GCF, check if you have 1 here and 2. So if A is 1 and the degree is 2. And the degree is 2, okay? Meaning the degree is 2. If you have 1 here and 2, again, we can immediately start with two sets of parentheses. So now we need to find two numbers that multiply to what?
12.
That's right. We need to find two numbers that multiply to C. Okay, two numbers that multiply to C, which happens to be positive 12. Same numbers should add up or subtract to
7.
That's right, to 7. To B,
And
positive 7.
3 and 4.
Exactly. So the numbers we're looking for are 3 and 4. So two numbers that multiply to 12. Start with the multiplication because it's here. That narrows down the options here. So two numbers that multiply to 12 and also add up to positive 7 are 3 and 4. Both positive. 3 times 4 is 12. 3 plus 4 is 7. And that's exactly what we want. So we were going to use, depending on their signs, you either add or subtract the numbers. That's it. So both of these must be true, must be met, these two conditions. And if you do, then all you have to do is just put the numbers here. They both happen to be both positive, but they're not always both positive. And that's it. That's your factoring of this trinomial, even though we don't have a common factor. There's no common factor or letter, but we can still factor in this special case. So these are special formulas. And how do we check? How do we check that this is the right factoring?
We multiply them.
Distribute.
Exactly. We can just distribute back. If you're wondering, or if you're skeptical whether this is correct or not, you can simply distribute, combine like terms, and you will get back to this. So that's, again, a special formula, special way to factor. When we don't have GCF, when we can't use grouping, the two methods that we learned last time. So this is another one of those formulas. So that gets a little more interesting. Okay, that gets interesting when you have a minus here or both. So with two positives, it's pretty simple to figure out the numbers, but it gets a little more challenging if you have a minus or two in there. For example, if we have, let's say, plus x here and minus x equals 0. I mean, not equal 0, just expression, not an equation. So same thing, we want to factor this, but it looks like we don't have a common factor. There is nothing common. The x is not common because it's not here. So again, check if it's a trinomial of second degree. It's a trinomial and you have 1 here and 2, 1 and 2. So that's again when you start two sets of parentheses, start each one with x. Now we need to find two numbers that multiply to what? Two numbers that multiply to
6.
2, 6 or negative 6 to be specific. So we need two numbers that multiply to c. Again, c to negative 6. Same numbers we used here. Whatever they are, when we combine them, we need to get exactly what is b. What's b in this trinomial?
It's 1.
That's right. So the b here, which is 5 here, is actually positive 1 here. So what if it's negative? It would be negative 1. So two numbers that multiply to this, same numbers should add up or subtract to this number, positive 1. So again, with the minuses, it gets a little tricky. So try to find two numbers that multiply to negative 6. Those same numbers must add up to 1. So what numbers do you think we should use?
5 and 1.
Okay, you can try 5 and 1. So 5 and 1. One of them has to be negative, right? Let's say, for example, negative 5 and 1. But will you get 1 from adding or subtracting 5 and 1? Will not be able. Okay, we can't get 1 from, so maybe for multiplying we get negative 6, but if you add them or
3 and
subtract,
minus 2.
Maybe 2 and 3.
Minus.
that's right. So 5 and 1 is not going to work. It may work for this, but it's not going to work for this. So it has to work for both. So 5 and 1 doesn't work. Then try 3 and 2. So 3 and 2 to get 6. So we want to get negative 6. So one of them has to be negative, but which one? It has to be a specific one. When we combine the same ones, we should get positive 1. So what numbers, what signs do we use for 3 and 2? So when we multiply them, we get negative 6. When we add them, when combine them, we get positive 1. What numbers or what signs? So again, let me repeat. So two numbers that multiply to negative 6 and add up to positive 1. 5 and 1 didn't work. Now we're going to try 3 and 2. So 3 times 2, they multiply to 6, but we want negative 6. So one of them has to be negative. But which one? Which one has to be negative? It will depend on this. When we combine the two,
Minus 2, yeah.
3 and minus 2, that's right. When we combine them, we have to get positive 1. So the numbers are, so 3 and negative 2. So 3 times negative 2 is negative 6. If we combine them, it would be 3. 3 and 2. 3 minus 2 would be positive 1. So same numbers and the same signs, 3 and negative 2, 3 and negative 2. If we multiply them, we'll get negative 6. And if we combine them, meaning add or subtract, we get positive 1. So the numbers are positive 3 and negative 2. So those are the numbers. Okay, so that's what we pretty much do every time. And we just need to figure out the numbers. But you should know your signs here. There's no room for mistake here with the signs. You should know your signs very, very well. The signs of addition and subtraction. You should master those because all this is based on that. If you have problems with those, review them because that would make this a lot harder. Okay, so we use all the signs of multiplication for the first part, and then addition and subtraction for the second part. So again, you have to know your signs well, so you can easily find the numbers. This is a special method, so it's quick. When you know how to do it, it's actually quick. You can immediately factor. You don't even have to write this down. You can just find the numbers in your head and immediately write the factoring of it. So let me give you another one. So let's say you have maybe so same thing here. We want to factor this using this special method, trinomial factoring. So first again, before you use this method, make sure you have 1 here and 2. Make sure there's an invisible one, the A basically is invisible 1 and 2. Because of that, we can write the parentheses. And then we're going to find 2 numbers. So what numbers are we looking for here? Or those numbers multiply to what? And add up to what? The numbers we're looking for. Based on this problem, the numbers that we need to put here, they should multiply to what number? And add up and subtract to what number? Everybody, what numbers they should multiply to? What number they should add up to based on this trinomial? Just like the previous ones. I'm not looking, don't give me the numbers yet, just what number they should multiply to. What should this number be from here? You must multiply to what and add up to what?
3 and 2.
No, just they have the 2 numbers we're looking for. I'm not looking for the numbers yet, just their multiplication. They must multiply to what according to this, and they must add up to what? If we multiply the 2 numbers, what should we get from here?
Multiply to 6 and add up to -5.
That's right. So the numbers we're looking for, they must multiply to this +6. Same numbers we use here for multiplication. When we combine them, whatever the signs are, we should get exactly this, B, -5. So the numbers must multiply to C and must add up to B. B is next to the X.
-2 and -3.
Okay, so you said -2 and -3. Okay, let's try that. So -2 times -3 is in fact +6. If we combine them, if we combine -2 and -6, I mean -2 and -3, yes, we do get -5. -2 times -3 is exactly +6, exactly C. When we combine the same numbers, we multiply here, same signs, don't change the signs. Same signs we used here, use them here for combining. -2 and -3 is in fact -5. So we have exactly what we want, +6 and -5. +6 from the multiplication, -5 from combining the 2 numbers. So this is exactly what we want. This is perfect. So +6 -5. So again, if you have a minus here or 2 minuses, be more careful. Play around with the numbers. You have to get exactly C from the multiplication and exactly B. C is here, B is here. This is again a trinomial of degree 2. And we have an invisible one as A. Invisible one as A here. Okay, so every time, basically that's the same method we can apply every time. When we use trinomial factoring, it has to work that way. We have to find 2 numbers and multiply to C and add up to B. So start with the multiplication. Usually you don't, this narrows it down. You only have a few options that multiply to 6. And based on that, looking at B, you can figure out which numbers to actually use. Because only one combination works, only one. It works for both to multiply to this and also works for addition to add up to +1. Okay, everybody, are you getting this, everyone? Everyone, this is a special method of factoring. So again, it should be pretty quick. It's not that difficult. Usually we could do this in seconds. You just need to know the signs, okay? The signs of multiplying, adding, and subtracting. Those are very important here when it comes to this factoring. Any questions so far, everybody, before we move on to another one? Okay, so let me give you another one. So, for example, x to the second minus x minus 6. See how the sign changes here? And the factoring changes. The factoring changes also. Actually here, the numbers we're looking for are not 6 and -5. The actual numbers we're looking for are -2 and 3. That's what should go here. -2 and 3. 3 and -2 here, 2 and 3. Not the 5 and 6, actually. This is what should go here. The -2 and the -3 are the numbers. They are the numbers that multiply to this and add up to this. So let me correct this. So again, two numbers that multiply to +6 and add up to -5 are -2, -3. Okay, so those are the numbers we're looking for. Do the same thing. So what numbers multiply to -6 and add up to, what is b here, by the way? What is b?
-1.
X.
That's right. The b is an indivisible -1. We have -x, which means -1x. So we need two numbers that multiply to -6. Same numbers add up to -1. What numbers do that? So first again, I'm going to start the parentheses. So we need two numbers here that multiply to -6. Same numbers add up to -1. Or with the numbers here. A lot different than this. It's based on this, but not exactly the same. As you can see here, we're looking for -6 and +1. Here we're looking for -6 and -1. So what numbers multiply to -6 and add up or subtract to -1?
-3 and +2.
-3 and +2. Let's try that. -3 times 2. That's -6. That's good. -3 combined with +2. Yes, it would be -1. That's right. So as you can see, the sign changes a little bit. So the numbers are -2, -3 and 2. -3 times 2 is -6. Exactly this. Same numbers we used here for multiplication, same signs. When we combine them, we get -1. So -3 plus 2 is -1. So the numbers are -3 and 2. And that's it. So again, this can be convenient, can be very quick. Again, once we figure out the numbers, which is not too hard to do. And again, even though we don't have a common factor, we were still able to factor. Even though there's no common factor here, we can't use grouping. We were still able to factor, return the addition or subtraction into a product. The end of factoring is always multiplication. So we have a multiplication here, and so on. And you can easily again check that this actually is true simply by distributing, combining like terms. We'll get back to this. So again, this is a special factoring method that's quick and also we use even if we don't have a common factor. Okay, any questions so far, everybody? This is very important. We're going to be using this a lot, extensively for the next 3 or 4 classes. I'm going to use this to solve other problems. So almost every problem would be factor first. First factor and then do something else, like solve or simplify or multiply or whatever. So we're going to use this a lot. All the factoring methods, the 2 we saw last time and the 2 we're going to see today, including this one. So will be used extensively, like I said, for other subjects. Please make sure you understand this and let me know if you have any questions. Okay, so it works the same way over time. It's basically just a multiplication and addition problem. That's what it is. It's basically this addition and subtraction problem. So the signs are important. Just need to figure out the multiplication first. And from that, we can also figure out the addition and subtraction. So this is, again, standard form. We look for two numbers that multiply to C, whatever the C is. Same numbers we use here must add up or subtract to B. B is next to the X, C is by itself. So this is the standard form of basically trinomials of second degree. Trinomials, you have three terms and of second degree. So if you have second degree for trinomial and you have one here, this is how you factor the trinomial immediately. We could give you another one. Go back, give you another easy one with just pluses. Say you have maybe 9x plus 20. So first of all, there's no GCF. If we have GCF, factor using the GCF first. If not, try trinomial factoring. Can we use trinomial factoring here based on this? Are the two conditions to use trinomial factoring met in this? In other words, do we have this in this trinomial? Is A 1 and the degree is 2 of this trinomial?
The numbers 4 and 5.
Well, before we use that, are these conditions met? Are these two conditions? Is A1 and B, is A1 and D is 2 in this trinomial? A is A1 and is the degree 2 in this trinomial?
Yeah.
Everybody? Yeah, so we're gonna make sure we do that before we use the parentheses. So again, make sure you have an invisible one here. If it's another number, then this wouldn't work. This would not work. This again is special factor. It only works.
Professor, hi. Sorry, I'm late. You will have you record it, right?
Yeah. This will be on Blackboard.
Thank you.
So again, before we use a special method, make sure you have A, you have 1, or A is 1 and degree is 2. Only if you have 1, so there's an invisible one here, and the degree is 2, this trinomial, so we can immediately start this. Without those two conditions, we wouldn't be able to do this right away. We're going to have to use another method, maybe GCF or something else. Okay, now we need two numbers that multiply to what and add up to what again, everybody?
Multiply to 20 and add up to 9.
That's right. Two numbers that multiply to 20 or positive 20, same numbers should add up to positive 9. What are the numbers again?
4 and 5.
4 and 5. Why? Again, because if we times them, positive 5 times positive 4, we get C for positive 20. If we add them, combine them, we get B. And that's it. So this is basically how you factor using trinomial. So you find two numbers that multiply to C, same numbers that add up to B. So I'm going to write that down, two numbers. Two numbers that multiply to B. Again, to C. C is this number that's by itself. And add up to B. Okay, so that's important. That's how you find the two numbers. Again, first make sure this is met, meaning A is 1 and degree is 2. So that's why we call it special factoring. Now let's see what happens if, what happens if you don't have 1 here. So all these problems, you can see we have x by itself, x to the second is an invisible 1 here. Let's see what happens if you do have, let's say, a number here other than 1. So when a is different, then a is different than 1. So it's going to be a lot of different. Let's see here, maybe give you another example. Let's say 3 x to the second. So look at this problem again, everybody. So again, before we apply this, before we do what we did here, first we try to find, check if we have a and 2. If you have 1 here and 2, you can use what we just did. If a is not 1, for example here, a is not 1, so we're not going to use this right away. This is not going to work. So what we're going to do is we're going to find 2 numbers that multiply. 2 numbers that multiply to not just c, but actually AC. Okay, AC. 2 numbers that multiply to AC. In this case, AC is 3 times 4, which is 12. So we need to find 2 numbers that multiply to AC. Same numbers, add up or subtract 2. Again, same thing here, B. Same thing as before, B, which is in this case 7. Let me repeat that. If you have a different number than 1, so the numbers we look for should multiply to whatever AC is. AC means A times C, in this case 3 times 4 is 12. And same numbers used here, same number used here to multiply to 12. We use them here to add up to 7. So what numbers do that? What numbers multiply to 12 and add up to?
In this case, 3 and 4.
That's right. So 2 numbers are multiplied to 12. So now just look at these two numbers are multiplied to 12 and add up to 12 or 7 or 3 and 4. Okay, even though we didn't have 1 here, we're still able to factor. So 3 times 4 is 12. Same numbers here, same number used here. They're not always the same, by the way. It's not always going to be the same as this. Okay, it's just a coincidence. So let me erase this from here. Doesn't have to be the same numbers as the numbers we multiply to this. This, for example, could be 6 and 2, for example. 6 and 2 is 12, but the numbers we look for might be different. So 2 numbers are multiplied to 12 are 3 and 4. Same numbers that add up to 7 are 3 and 4. So 3 plus 4. So let's check. 3 times 4 is 12. 3 plus 4 is 7. So that's the first step. Again, we're not using the parentheses like this right away. We're not done yet. So we don't use the parentheses. We can't start the parentheses like this and put the numbers here because, again, this is not 1. This is different. So what we do is, so we take, so once you find the numbers, so the numbers are 3 and 4, we take the middle term and we split it. We take that middle term and we split it based on this. So 7x could basically be 3x plus 4x. So we split it with an addition here. So so 7. Okay, so we take that middle term and we turn it into 2 terms. So instead of 7x, we split it into 2 terms. which is 3x and 4x. That's the second thing you do when, again, this is not 1, it's different. That's why we didn't use the parentheses right away. So we found the numbers that multiply to AC and add up to 7. So only change these two into two terms. The other ones should stay the same. Okay, that's the first step. Now, if you remember from last time, we used grouping. There's no GCF still, there's no GCF here, but we can use grouping like we did last time. So we can factor these two together and factor these two together, just like we did last time, and we'll end up with some common factor at the end. So let's factor the first two using the GCF. What is a GCF here, everybody? So this is basically what we did last time. So this is not new. This is what we did last time. What is a GCF for the first two?
3. No.
3 is a common, that's right. It's in both. What else besides the 3?
The x.
The x, we have x2, x1. The lower power is the common factor. So 3, x1 is the common factor. And we just factor in these two. Don't worry about these two yet. Okay, what do we get now? So that's the GCF. What do we do to complete the parentheses?
X plus 1.
X plus 1. So we're going to divide this by this. We get x plus 3x divided by 3x is 1. It's good. So we factor the first group. Let's factor the second group. What is the GCF?
4 parentheses x plus 1.
That's right. The common factor here is 4. Divide by 4 is x. Plus 4 divided by 4 is 1. Okay, so we factored each group together. What do we do next now? Or what is the common factor between these two terms?
X plus 4.
That's right. So now we have a new common factor for these two. It's x plus 1. That's the new common factor. We write it out first. Open the parentheses. And if we divide both by x plus 1, we divide these two, we get 3x left. If you divide this by this, we get 4 left, plus 4. That's it. As you can see, we factor. This is the factor, the factoring form of this. And if we distribute it, if you want to distribute, you'll get back to the same problem as here. So again, let me just recap what we did here. We had to find, because this is not A, this A is not 1. If it was 1, it would be easy. We'd do it in one step. If we have an invisible 1 here, just like we did with all these problems, just have to find two numbers that multiply to this and add up to B, whatever this is. And that's it. You put them immediately in two sets of parentheses. You start each one with x. But if you don't have 1 here, you can't use this. If you have a different number, for example, 3, what you have to do first is find two numbers that multiply to AC, meaning this times this. This times this is 12. So you need two numbers that multiply to 12. And same numbers, just like here, same numbers add up to B, 7. So the numbers that multiply to 12 and add up to 7 are 3 and 4. Once you find those numbers, again, if this is different than 1, A is different than 1. Once you find those two numbers, you go to the middle term and you split it. The middle term, you split it based on the addition, based on this addition. So instead of 7, we use 3 and 4. So instead of 7, we use two terms, 3 and 4. Why? So we could be able to factor by grouping. So once you split this term into 2, then you factor each group together. And after that, just like we saw last time, this is factored by grouping. And we were able to factor it, as you can see, we turned it into this. From additions to a product, which you can easily verify by distributing. And you'll see that it goes back to this. Okay, let me give you another one of these, okay, everybody? Watch out for this problem. We'll give you another one. And let's see. So we're gonna need two numbers and multiply to maybe maybe something like this. Well, let me actually make it a little different. So let's say maybe 5. All right, so there's another example. You want to find two numbers. Okay, so we're going to find two numbers here that multiply to what? Everybody? So we want to find two numbers that multiply to what? Again, because A here is different than 1, so we can't use the parentheses right away. We'll have to find two numbers that multiply to a certain number, then same numbers multiply to something else. So we need two numbers that multiply to what? Based on this.
6 and minus 1.
Multiply to AC, right? A times C. What is A times C?
106.
That's right. Two numbers to multiply to AC is,
-6.
or AC is -6. Then the same numbers should add up to B. Okay, same numbers add up to B. B in this case is +5. All right, so what numbers multiply to -6? Same numbers when combined add up to +5.
Wait.
What is
Could
it?
you repeat the question, please?
So two numbers are multiplied to this and add up to this number.
-1 and 6.
-1 and 6, okay, let's try. So -1 times 6 is in fact -6. So two numbers are multiplied to AC. And the same number we used here, they must add up to B. So if we combine -1 and 6, we combine -1 and 6, we get, in fact, +5. So these are the numbers we're looking for. So again, look for two numbers that multiply to AC. And the same numbers you use that multiply to this, to -6, must also add up to +5. In this case, -1 and 6. Okay, that's the first thing. Well, now we have the numbers. What do we do after that? What do we do after this?
Factoring by grouping.
Factoring group. Okay, what specifically do we do with this trinomial? So I'm going to write it again. What exactly do we do with it right now? Or which term?
Divide 5. You have to
We split the first.
Yeah. 3x and plus 2x, I guess.
Not 3x plus, it's going to be based on the numbers we found here.
Ah,
So it's going to be based on this. So 5x,
That would be +6 and then -1.
that's right. So we're going to split it based on this. So based on 6 and 1. So 5 is basically +6 and -1x. Still equal. All we did was turn this into 2 here. Bring this other one down. Bring the -1 down. Now we can use grouping. Okay, you may have to move the terms around. Okay, you may have to move something around so we can have two groups to factor. So these two in common again, what do they have in common?
6x.
6x. Try if we factor them.
X
We
plus 1.
divide, would be x plus 1, just like the previous one. And what is common in between these two?
-1.
That's right, -1. Open the parentheses. Divide this by -1 would be
X plus 1.
X, that's right. And -1 divided -1 is +1. Now what do we do? Everybody, what do we do now with these two terms?
So 6x minus 1.
Mhm.
We factor x plus 1 in this case.
That's right. X plus 1 is the common factor. So we're going to write it out first. Open the parentheses, so 6x minus 1. So x plus 1 moves to the front, and we have 6x minus 1. So that's basically how you factor when a is different. So when a is different than 1, we have to do this. And when a is 1, it's actually quick. When a is 1, you just need to find two numbers that multiply to this and add up to this. We can do it in one step right away. This is a little more complex, the second one, because a is different than 1. So that's how you factor trinomials. So after the GCF doesn't work, if you don't have a GCF, then you try trinomial factoring. First, check if an is 1 and d is 2. You do all this. But if a is not 1, is different than 1, then we have to first find two numbers that multiply to AC. Same numbers should add up to B. We split the middle term, we use grouping and so on. So that's basically how you factor trinomials when you don't have a GCF. By the way, if you have a GCF, first factor the GCF out. That's the first thing you do if you have a GCF. If the GCF doesn't work, and if grouping doesn't work, that's when you try this special factoring. So we have two of them. Trinomial factoring is what we just saw. Now we're going to see another one, another special one, a lot different than this, called difference of two squares. So this is the second method. So this was trinomial factoring. This one is basically called binomial factoring. Let's see how this works. Previously, we saw that we can factor something like this. So this is a binomial. Okay, so binomial, we can factor it. I'll always look for the GCF first. What is the GCF or the common factor here?
3.
3. That's right, 3. We open the parentheses. And what do we have inside? The parentheses, if we divide by 3, x plus 2. So this is a binomial. We factored it, no problem. Okay, it was easy because we had a common factor. But if we don't have a GCF, so this is again the GCF. If we don't have a GCF, that's when we have to have this special formula. So let's say you have x to the second minus 25. So it's also a binomial. It has two terms, but we don't have a GCF. There's nothing common between these two terms. So if you recall, if you remember, we did this before with multiplying polynomials. We multiplied something into this. So factoring again is the opposite. Factoring is the opposite of multiplying. So actually you can see it from here. So basically, so here we multiply. If you go back, if you factor, you would go back to the other, I mean, actually the other way around. One way we factor, the other way we multiply. So here we factored. But to go back, just distribute, and you will go back to the other expression. But here, if you remember again, we used the formula for multiplying polynomials. There was something that multiplied immediately into this. What was that formula, if you guys remember it? We saw that a minus b a plus b times a plus b. What is this equal to again? From the multiplying polynomials. It's in one step without distribution. What do you get?
A square
So a squared minus
minus B square.
b squared. That's right. So we use this for multiplying. You can also use it to factor. That means if you have something like this, you can turn it immediately into this. So if you use this, if you apply this to this, okay, this is this is already so basically you have this. We want to make it back into this. So what would this be equal to? If you look at the expression, the formula, or let me rewrite it the other way. So we said basically a minus b times a plus b. We said if you multiply this, it's equal to x a to the second minus b to the second. Now let's apply that to this.
So it's x minus 5 multiply x plus 5.
That's right. So this is what we call the difference of two squares. The difference of two squares. There is one square minus the other square is here, 5 to the second. So that's why it's called the difference. Okay, the difference of two squares. Difference means a minus and two squares. And as you can see, it looks like this. Once you have it, you can turn it immediately into x minus 5 and x plus 5. Just like the formula. So this formula can be used in two different things. Whether you're trying to multiply, if you multiply this, you'll get back to this. Or if you have this, you can turn it into a product. So we talked about it before, and I told you it's very useful and that we would talk about it when we do factoring. And this is when we use it. That's another special factoring formula when we don't have a GCF. When we don't have a GCF like this, we use a difference of two squares. It has to be a minus. Okay, this works only if you have a minus, not a plus. If you have a plus, it's not going to work. It's not going to factor if you have a plus. So that's basically what I mean by the difference of two squares. It's very useful. And you can use it right away in one step, actually. You don't have to break it down into this step. You can just turn it into this. Just like you can use this. You can use this immediately to multiply without having to distribute and combine like terms. This can be turned into this immediately. So let me give you another one. So x to the second minus 36. What is that equal to again, according to the formula? One in one step.
X power 2 minus 6 power 2.
That's right. So we have a square here. This is basically 6 to the second. This is 6 to the second, so it's going to be x minus 6, x plus 6. So you see we factored it, even though there is no common factor between the two. But because it's two squares and a subtraction in between, we turned it into this immediately according to the formula. And again, if you have something like this and you want to multiply it, you can also do it in one step. Just take the first one and square it minus the second one squared, and you will get this. So that's how the difference of two squares works. It's pretty quick and easier. So even if you don't have a GCF, if you have the difference of two squares, so difference is because of this minus. Difference because of the minus. So you gotta have a minus, not a plus. Difference means subtract. And then I'll give you another example. So we want to factor this binomial. So what do we do first to factor this binomial? In other words, do we have a GCF? Is there a GCF? Everybody, is there a common factor here? Before we use any special formulas, do we have a GCF or a common factor?
2.
2 is a common factor, right? So GCF, always try the GCF first. always try the GCF first. And after you do the GCF, then you look for something else. So 2 is a common factor, so we're going to do 2. That's the only thing common, open the parentheses, just like we did here. What's inside the parentheses now?
X power 2 minus 9.
That's right. If we divide by 2, you get x to the second. Minus, also divide by 2, you get 9. So now we just use the GCF, okay? Just the regular factoring we did last time. That's the GCF. So after the GCF, always try to see if you can factor again, whether it's a binomial like this, or if it's a trinomial like this one or that one, you try to factor again if possible. So you need to factor completely, factor as much as possible. So can we factor this more?
Yeah, according to the rule above,
Mm-hmm.
x
So it
minus
looks like
3, x plus 3.
that's right. So this is the difference of 2 squares again. We can apply this to the parentheses. So we have 1 square minus another square. This is basically 3 to the second. So it's like 8 to the second minus 3 to the second. It would be 2 x minus 3 and x plus 3. So so we use GCF and then binomial factoring. So we factor twice. So first, always look for GCF. And then after the GCF, then you might try either grouping. You may try grouping. You may use trinomial. Or even binomial, just like this example here. But again, you need to try the GCF first. That's what you have to factor first. Factor that out first, then you might need to factor again after the GCF. Let me give you another one. So let's say you have x to the second, maybe plus 10x 3 plus 18. This one is not a binomial, obviously it's a trinomial. So how do we factor this? Everybody, how do you factor this binomial? What's the first thing we look for?
Do we have
Just like you did, you'd factor. Oh, sorry.
I'm sorry, repeat that. How was that? I'm sorry. Someone said something.
well, we have to take a look if we have GCF.
GCF, exactly. Always look for a common factor first. GCF, common factor meaning a number or a letter that's in all of them. Before we try any of the special methods, we have to find the GCF. Do we have a GCF here?
3.
3. So let's factor out the 3 and see maybe we can factor again. So, okay, so 3 is common. Let's divide all of these by 3. What do we get inside the parentheses? If we divide this by 3, it would be,
X squared
okay, plus
plus 5x
5x plus
6.
6. That's right. Now, you see we have a trinomial inside. Can we factor this trinomial like we did earlier?
Yes.
So we have 1 here, we have 2. So this stays here. Since we have 1 here and 1, 2 again, we can immediately start 2 sets of parentheses, open x, or start each one with x and x. So we need 2 numbers that multiply to 6 and add up to 5 to put in the parentheses. What are the numbers again? We saw this earlier.
3 and 2.
3 and 2. So this is just basically the same example, the first one we did. So 2 numbers that multiply to 6 and add up to 5, 2 and 3. So after we did the GCF, we continue to factor. So 2 and 3. Okay, so GCF first. And then we used trinomial. Here we use GCF then binomial, but here we used trinomial. So this is complete now. There's nothing else to factor. This is complete. So always again, look for GCF. That's the first thing you want to try, the GCF. Then after that, you can possibly factor again if you end up with one of these situations. So check your expression and see if it meets the trinomial factoring, meaning 1 and 2, or if you have a difference of 2 squares like this one, and you use it. So that's basically, so you gotta basically factor twice, or as the problem says, factor completely. So when it says factor completely, don't just factor 3 and stop. You need to look at the expression and see if you can factor again. The expression, well, the problem is not going to tell you how to use, what to use, or how many times to factor. It's up to you to factor completely. Okay, any questions so far, everybody, about the difference of 2 squares? Everyone, other than the 2 or 3 students that I talked to? Everybody, any questions before we move on? This is again very important. The factoring is going to be used for the next, 3 or 4 classes extensively. So make sure you understand your factoring, the 2 methods we did last time and these 2 here. Let me give you another one. Let's say when you have 9 active second, maybe minus, say maybe 81 or just maybe 25. So we want to factor this again. As always, what is the first thing we try to factor? Everybody, what is the very first thing we try? Or do we have a GCF?
No.
Do we have a common factor? There's no common factor here, right? So unlike here we had 2 in common, but here there's no common factor. So now we're going to try to, looks like obviously we can't use binomial. I mean, we can't use trinomial. This is not a trinomial. We can use grouping. Grouping requires 2 groups. But since this is a binomial, let's see if we can use binomial or difference of 2 squares. Can we use that? Can we use this formula, the difference of 2 squares? Can we use it here? Or can we make 2 squares out of this?
We can.
Only if we use fractions, I think.
Not necessarily. At least we can make this one into a square easily, right? That's 5 to the second. The number that I was thinking about actually, not 6. 6 is not going to work. Let's make it 9. So at least we have a square from here. Can we make this one a square, a perfect square?
3.
Yes.
Okay, what is it? The whole thing as a square would be
3x squared.
3x squared. That's right. So difference of 2 squares, you gotta have 2 perfect squares, 2 complete squares. This is easy to get. This one doesn't only have x to the second, it has 9, which is basically, so 9 x to the second is basically 3 to the second and x to the second. And since these 2 have the same power, we can group them together to the second power. So 3x to the second, that's why we have 3x to the second here. Now it looks like this. So we have the difference of 2 squares, 2 perfect squares, the difference, just like this one. We can turn it into this. So what is this equal to if we apply the formula? What does this become? So basically we have this, we just want to make it into this. So what do we get?
3x minus 5 that multiplies 3x minus 5.
That's right. So 3x minus 5. So basically just take the bases. So if you have the difference of two squares, you take their bases, a minus b, without the second powers, a minus b. And then you repeat again the bases, this time with a plus. So we have 3x minus 5, 3x plus 5. And that's it. This is it. So we made two squares. So the two squares might not always be visible. You may have to make them visible first. For example, here we had to turn the 5 into 5 to the second. Other times you may have to look at the two terms first. Look if you have a GCF. If you don't have a GCF, this if you can make two squares. Most of the time it would be pretty easy to make a square out of it. So we have a square here, we have a square here, and we turn it into this. Other times you may have something like this. Say x to the third, and or actually not to the third, maybe x to the sixth, minus, let's say, 49. So again, always look for a GCF. We don't have a GCF here. Can we make two squares out of this? Can we make two perfect squares since we have difference?
X squared and third square in third.
Okay, so we're going to try to make this. Again, we have to have second power. So we need a second power, two squares. At least this one is easy to make into a square. That's
So
7 to
we
the
can make
second.
it x on the third whole in the second.
Exactly. So basically what we have here is we have x to the 6, but we want to get power 2 out of it. The outside power, we need to have a 2 here. So we have 2 here. These two multiply to 6. So this one has to be 3. So 3 times 6, as we saw before. So we saw this rule before with the rules of exponents. Here's another rule of exponents. Because this is the same as this. Because we times the 2 to get 6. So we want the 2 to be outside. You could flip them, but we want the 2 to be outside so we can have 2 squares and a minus in between. We have a minus, we have the first square, there's the second one. And that's it. Now we have two squares, two perfect squares. We have a minus in between them. So according to the formula, what is this equal to now? According to the formula.
X3 minus 7, x3 plus 7.
That's right. So we take the bases without the second powers, whatever the base is. So x to the third minus 7 and x3 plus 7. So again, you may have to work on making your perfect squares. Might be as easy as this, or you may have to look at the expression and try to make two squares out of it. But again, make sure you have a minus in between, a minus, not a plus. So this doesn't work with a plus. It's what we call the difference of two squares. So the difference, again, means minus of two squares. It has to be a difference in between, not a plus. If you have, for example, x to the second minus or plus plus 5 to the second, this does not factor. Okay, it does not factor. It's not like this one with a minus. So this is what we call a prime. Prime can't factor. So keep that in mind. Not every polynomial can be factored. Not every number can be broken down. You may break down, for example, 15 into 5 times 3. So these are factors of 15, 5 and 3, but 17 does not break down. You can only write it as 1 times 17. So this is composite, but this is a prime number. This is a prime number. This is composite. So not everything can be broken down or turned into a multiplication. Maybe we turn this into a multiplication. This we cannot turn into a multiplication. Same way we cannot turn 17 into a multiplication other than 17 times itself. We can turn this into this times itself, 1 times this, but that's all. We can't we can make it into, for example, 2 parentheses like this. So that's how binomial factoring works. First, again, try the GCF. If you have a GCF, that's good, factor it. Then if you end up with a difference here, maybe try to make 2 squares out of it. If you have 2 squares like here, factor more. If you have a plus, you can't factor anymore. There's nothing you can do after that. Even if it's a trinomial, first always look for a GCF. If you have a GCF, factor it. And after that, try to factor again. See if you meet any of the criteria we talked about again, 1 or 2 here, or even if you have a different number here and a different and a power 2, see if you can use this method we talked about earlier, finding 2 numbers that multiply to AC and so on. So those are the 4 methods of factoring. So we saw this one last time, we saw grouping last time. Today we did trinomial and binomial. So these are all the 4 methods of factoring we're going to be using. Again, we're going to be using them extensively, a lot. So we have to understand these, you have to know them in order to be able to do the next few topics. At least, like I said, maybe 3 or 4 topics will be 80% of it will be basically just this, just factoring. So always look for a GCF first, and then use the GCF to factor, and then try again to factor using one of these. Or if the GCF doesn't work, then try one of these, see if you can use one of these. Just keep in mind, sometimes you can't factor. Whatever you do, you won't be able to factor. That would be called prime. For example, this is prime. And also if I said something like this, for example, this. So can you find 2 numbers that multiply to 1 and add up to 4? So if you want to factor this like we did before, you have 1 here and 2. You won't be able to find 2 numbers that multiply to 1 and add up to 4, no matter what you try. There's only 2 numbers that multiply to 1. Those are 1 and 1 or -1 and -1. Integers, I mean, 2 integer numbers. And you can't get 4 from adding or subtracting 1 and 1. So sometimes you can't find the numbers. In that case, again, this is, you can say it's prime. Not every polynomial can be factored. So if you try all of this and none of them works, that's okay. In that case, you can say it's prime. But if they don't work, you can say it's prime. So you may come across polynomials in the homework or whatever that you can't factor. That's not a big problem. Just make sure you try everything. And if everything doesn't work, again, you can just say prime polynomial can't factor or something like that. Okay, everybody, any questions about factoring? Everyone, any questions? Please let me know. So as always, you will find the recordings of this on Blackboard. I highly recommend that all of you rewatch and watch the 2 factoring lectures, this one and the one before, because again, this will be used a lot and it's very important for the next few topics.
Professor, when you upload the today class?
There should be something there already identical to this. If not, I'll do it. I'll do it soon.
Yeah.
Actually, there might be even 2 versions, not just one. Each lecture has 2 versions with completely 2 different sets of problems. So you have plenty of problems to go over. Okay, so again, this is an important topic. It may seem a little tricky in the beginning, I understand. Especially this one here with the signs. So, but with practice, you'll see that it's easy. With practice, you will be able to do this in 3 seconds. These numbers here, you can find in 3 seconds. And this takes literally 1 step. This one takes a little longer because it's a little different. But again, practice makes perfect. So, and in order to do any of this, you have to know your signs. The signs are very important. You can't be stuck with adding 2 numbers and multiplying 2 numbers. You need to know that in order to be able to do this. And also make sure you know your powers, your exponents and rules. Those are basically the backbone of this class. The exponents and their rules, in addition to factoring, are basically very important for this college algebra course. Okay, so we're gonna